Okay, so it says evaluate the infinite series by identifying it as the value of a derivative of a geometric series. It gives us this question. There's the answer, how'd they get it? Hint, here's the big hint. Write f double prime of 1/8, where f of x equals that. Okay, what I'm going to do is I'm just going to follow the hint, do the hint, we'll get this answer, and then I'll tell you afterwards why the hint is right if you care. But let's do it. Let's just follow the hint blindly at first. Okay, so I'm going to say, okay, so f of x equals the sum of x to the n over 64. Now, what does that equal? Well, this is where you got to, let me go all the way up here past some of my other work. Remember, go back to the notes. Here's the class notes. Remember this formula? This is the Chapter 6 Power Series class notes. Here is the main power series. This is the geometric series. The sum of x to the n is 1 over 1 minus x. Going to use that one all the time. Okay, so let's remember that. Let's go back down. And we will use that. So the sum of one, so let me write that up here for us. The sum of x to the n is 1 over 1 minus x, right? Okay. So this, therefore, equals 1/64 times the sum of x to the n. And the sum of x to the n is 1 over 1 minus x. So this is 1/64 times 1 over 1 minus x, isn't it? You with me? So f of x, which equals the sum of x to the n over 64. Well, we know the sum of x to the n from the power series formula in the notes is 1 over 1 minus x. Okay, so now it's derivative time. So first derivative, we're going to go all the way to second here. The 1/64 just sits in the front, as you know, he's just a constant number. Now this, I'm going to rewrite this as the 1 minus x to the minus 1. So I take the derivative, you know, the minus 1 power comes down. The minus 1, 1 minus x to the minus 2 times, drew to the inside, don't forget chain rule. Chain rule, drew to the inside, -1, right? Because there's a -1 on that x, derivative is -1. So that -1 cancels that -1. And the first derivative is 1 over 64 times 1 minus x to the minus 2, right? The two negatives canceled. Okay. Let's do a second derivative now. Second derivative. Okay, again, the 1/64 is just a spectator. He's watching. Bring down the minus 2. 1 minus x to the minus 3. Subtract 1 from the power times, chain rule, drew to the inside, -1. So then that second derivative will equal -1, and the two negatives cancel. So it'll be 2 over 64 times 1 minus x to the minus 3, right? I can rewrite that one more time. I'll make this, this is going to be 1 over 32. So that'll be 1 over 32. And this guy will bring down to the bottom, and then the power will become positive. Okay. Now, what did they want me to do? They said find f double prime of 1/8. So plug in 1/8. Okay. I'll just follow them blindly. Plug in a 1/8. What do we got here? Well, 1 minus 1/8 cubed. What's that? Well, that's going to be 7/8 cubed, isn't it? And really, you could just type into Desmos at this point, but I'll just do it by hand. So we got 32 times 7 cubed over 8 cubed, right? And so, um, yeah, you could do Desmos. You could do what? Yeah, I'll probably just do Desmos at this point. Or I'll just tell you, if you do Desmos, 7 cubed is 343. 8 cubed is, what is it? 122, 512. Okay. And then you can put this over 1. This goes into this. I can't remember. What is it? I think it's 16, yeah, 16 times. So we have 1 over 343 over 16. Flip that up, right? Dividing is upside down. Multiplying 1 times 16 over 343. 16 over 343. And I believe that's the answer that we were looking for. Yes, it is. Now, again, you could have typed it all into Desmos like right there. You know, you don't have to do all that stuff by hand. Let me show you. 1 over 32, 7/8 to the third. Okay, so 1 over 32, 7/8 to the third. Let me go to my Desmos. I guess I'm going to have to open it up. I just want to show you that because I don't want you to, like, you have to do 10 million things. There it is. Okay, I'm going to go to the Decimal Scientific, hit the fraction button. 1 over 32 times, parentheses, 7/8 to the third. And you think, oh, I get that weird thing. You just hit the fraction button. See the fraction button over there? Boom, 16 over 343. See that little fraction button that changes? You can give them the decimal or the fraction. There it is, 16 over 343. So we got it. That you can do that instead of doing all the steps by hand. Now, that's the answer. That's all you got to do. But why is it true? This is the extra part. This is the credits at the end. I hope you'll watch just see why that's true. Okay, yeah, so I did their hint, F double prime 1/8, and I got the right answer, but why? Why is, this is what we were saying that the sum here equals 16 or 343 because it's F double prime of 1/8. Why? Why? Well, let's take a look. So in fact, how about if I just well, I'll just go down there. So I'm just going to take this real quick and I'm going to prove it. So I'm going to take that the sum of n times n minus 1 um, over 8. So I'm gonna let me start with this. F of x is the sum, x to the n over 64. So remember, f of x is a sum from n equals 0 to infinity. I already forgot. What is it? F of x is x to the n over 64. Okay, x to the n over 64. Y is taking the derivative. Let's take some derivatives of the formula and show it's true. What I'm going to do is I'm going to take this formula. I'm going to take two derivatives and I'm going to plug in 1/8 and I'm going to show you that it gives me that formula, which means it's right. So let's do it. First derivative of that formula. Now, what happens when you take a derivative? This goes up by 1, n equals 1. Why? Because if you think about it, this formula is, you plugged in 0, it's x to the 0 over 64, and then plug in 1, plug in 2, etc., 64, etc. Well, this is what's x to the 0? 1. So this is a constant. So when you take the derivative, that's going away, and you're starting at 1, right? Okay, so take the, bring down the n. Oops. X to the n minus 1. The 64 is just sitting there. Why? It's just a constant. In fact, let's just get that out of there. Let's just make that 1/64 in the front. So it's just nx to the n minus 1. Right? See how that's right? If you plug in 1, you'll get 1 times x to the 0. And on you'll go, which is what the derivative of this would be, because you bring down the 1, that'd be 1 x to the 0 over 64. It's right. Okay, so we just took the derivative. Let's take a second derivative now of that formula. Okay, the 1/64 is just sitting in the front. Sum. Now the n minus 1 comes down. N minus, oh, this goes up by 1 again. Now we're going from 2 to infinity of x to the n minus 2. Right? Tracking with me? Okay, so now they said f double prime. So I thought I added a page there. There we go. F double prime, they said take f double prime and plug in 1/8, and you should get that formula. Do we? Now plug in 1/8 for x. 1/8 right there. So n minus 1, 1/8 to the n minus 2. What is that? Well, I'm just going to write scribbly with that sum. Sum, I'm going to go n minus 1. This 64th really means 8 squared on the bottom, doesn't it? And this means 8 to the n minus 2 on the bottom, right? Because this is 1 to the n minus 2 over 8 to the n minus 2, right? So you put that 8 to the n minus, whatever, n minus 2. There we go. 1 to the n minus 2 is just 1. Doesn't do anything, right? And so what does this equal? The sum n minus 1. What happens with these powers? Same bases, multiply powers, add 8 to the 2 plus n minus 2. And so that's n minus 1 over 8. These cancel. 8 to the n. So that, and that's from 2 to infinity. That's the original question they asked us, right? Do you see that? This, n minus 1 over 8 to the n, n minus 1 over 8 to the n. They're saying, what is that equal to? Well, we just proved that is this. That is the second derivative with 1/8 plugged in. We just proved it. We took the original f of x function they gave us. We took two derivatives and we plugged in 1/8, and that is our formula. So therefore, our formula is whatever the second derivative of 1/8 plugged in is, and then we've already found out what the second derivative of 1/8 plugged in is. Right here, we took the function they gave us, we took two derivatives, and we plugged in 1/8. I know power series are confusing, but you can get them. Just spend some time thinking on all these things. There we go.